Hello there, and welcome to a flipped learning video for Advanced Higher Mathematics, Partial Fractions 3. In this video, we're going to be talking about what we called earlier Type 2 partial fractions questions, one where there is a repeated linear factor in the denominator. So we'll get straight to it. Our first example is going to be expressing x squared minus 7x plus 9 all over x plus 2 in one bracket and x minus 1 squared in partial fractions. Now, let's look for a wee second at the difference between this one and the ones we were looking at earlier. Again, we have a denominator made up of linear factors, x plus 2 being one and x minus 1 being another, but this time the x minus 1 is squared. So we set this one up a wee bit differently. So I've got x squared minus 7x plus 9 all over x plus 2 x minus 1 squared is equal to something over x plus 2 plus something over x minus 1 plus something over x minus 1 squared. And as before, we'll call those somethings A, B and C. Now when we do our kiss and smile technique, again the denominators will disappear, and what we have to do is we have to multiply each something by the other denominators that didn't apply in the original fraction. So you can see here that A is over x plus 2. So you imagine getting rid of the x plus 2 here, and what are you left with? The x minus 1 squared. So what we're left with is x squared minus 7x plus 9 is equal to A times x minus 1 squared. Now plus B, well B is over x minus 1 at present, so in the original equation we've got an x plus 2 and another one of the x minus 1's. So x plus 2 and x minus 1. And C is over the x minus 1 squared, so in the original fraction the one that isn't applied there is the x plus 2. Okay, so once we've done that, we can now do the same procedure that we would normally do. So I need to pick three values for x, one to find A, one to find B and one to find C. So to find A, I'm going to let x be equal to negative 2. Because if x is equal to negative 2, this will disappear, and so will this. So I'll end up with negative 2 squared minus 7 lots of negative 2 plus 9 is equal to A. That's going to become negative 3 squared. That's going to become 0, and that's going to become 0, so everything else is going to disappear. So I'm just going to be left with 4 plus 14 plus 9 is equal to 9A, which is going to give me 27 is equal to 9A. Therefore A is going to be 3. Now I'm going to find C, and the reason I'm going to find C is because there isn't a value I can pick for x yet that will wipe out A and C to let me find B. Okay, so I'm going to find C next. So to find C, I'm going to let x be equal to 1, because that will wipe out this bracket here and this one here. Everything else will disappear. So I'll be left with 1 squared minus 7 times 1 plus 9. That'll become 0, so that'll disappear. That'll become 0, so this will disappear, and I'll just be left with that C is equal, C multiplied by 1 plus 2. So I'll end up with 1 take away 7 plus 9 is equal to 3C, which will become that 3 is equal to 3C, therefore C is equal to 1. Now I need to find B, and we've got the issue that there isn't a value I can pick for x where A and C, or the brackets joined onto A and C rather, will disappear. However, we've already worked out what A and C are, so because of that we can actually use any value for x to let us find B. Now although we could use any value, practically you want to use a fairly small number that's easy to work with, so I'm going to find it by letting x equal 2. So I'm going to say that to find B, let x equal 2. So what we're going to have is we're going to have 2 squared minus 7 times 2 plus 9 is equal to A. Well, A is equal to 3. So that's going to be 3 times 2 minus 1 squared plus b, we still don't know what b is. That's going to become 4 and 1. And plus c, well c is equal to 1. So I've got this fairly lengthy equation here, but ultimately that's going to let me find b. Let's simplify it. So that's going to give me 4 minus 14 plus 9 is equal to 3 times 1 squared plus 4b plus 4. 4 take away 14 is negative 10, plus 9 is negative 1. So I get negative 1 is equal to 7 plus 4b. So therefore 4b must be equal to negative 8, and therefore b is equal to negative 2. So now I've got everything I need to finish the question off. So to finish the question off, I've got x squared minus 7x plus 9 all over x plus 2, x minus 1 squared is equal to a, which we found out to be 3, so it's going to be 3 over x plus 2. B was equal to negative 2, so that's going to be minus 2 over x minus 1. And c we found was going to be equal to 1, so that's plus 1 over x minus 1 squared. And there is my final answer. Okay, we've got one more example that we're going to look at. Okay, here's our second example. So we're going to express 3x squared plus 6x plus 5 over x minus 3, x plus 2 squared in partial fractions. So again, we've got a repeated linear factor on the bottom. So we set it up as follows: 3x squared plus 6x plus 5 over x minus 3 brackets x plus 2 squared is equal to a over x minus 3 plus b over x plus 2 plus c over x plus 2 squared. Then we'll use our wee kiss and smile technique. Remember, the denominators will disappear and I'll be left with 3x squared plus 6x plus 5 is equal to a times x plus 2 squared plus b times x minus 3 x plus 2 plus c times x minus 3. Now again, as before, I need to pick 3 values for x that will let me find a, then c, then b. So to find a, I'm going to let x be equal to 3. Because if I make x equal to 3, this bracket will become 0, this bracket will become 0, and everything joined onto the b and c will disappear. So I'll end up with 3 times 3 squared plus 6 times 3 plus 5 is equal to a brackets 3 plus 2 squared. So that's going to give me 3 times 9 plus 18 plus 5 is equal to a times 5 squared. And ultimately that's going to give me that 50 is equal to 25a, therefore a is equal to 2. To find c, I'm going to let x be equal to negative 2. So I'll have 3 times negative 2 squared plus 6 times negative 2 plus 5 is equal. Now this bracket will become 0, so this will disappear. This bracket will become 0, so all of this will disappear. I'll just be left with c times negative 2, take away 5. Take away 3. That's going to give me 3 times 4, which is going to give me 12. Take away 12 plus 5 is equal to negative 5c. Therefore 5 is equal to negative 5c. Therefore c is equal to negative 1. So now I just need to pick a value of x to find b. I haven't used x equals 1 before, and that's a small number that's easy to work with. So I'm going to say that to find b, let x equals 1. So I'm going to have 3 times 1 squared plus 6 times 1 plus 5 is equal, and now a, we worked out that a was equal to 2, so that's going to be 2 times 1 plus 2 squared plus b, we still don't know what b is, so 1 take away 3, 1 plus 2, and then plus c, well c was negative 1, so minus 1, 1 take away 3. So that's going to give me 3 times 1 plus 6 plus 5 is equal to 2 times 3 squared plus b, negative 2 and 3 minus 1 and negative 2. So 3 plus 6 plus 5, well that's going to be 14. 2 times 3 squared is going to be 18. That's going to be minus 6b plus 2. So I'm going to get that 14 is equal to 20 minus 6b, which is going to give me that negative 6 equals negative 6b, therefore b is equal to 1. And now I've got everything I need to finish my question off. So to finish my question off, my original fraction was 3x squared plus 6x plus 5 all over x minus 3 x plus 2 squared. And in partial fractions that can be expressed as 2 over x minus 3 plus 1 over x plus 2 minus 1 over x plus 2 squared. And there is my final answer. So thanks for watching, I hope you found that useful, and I'll see you soon for future videos. Cheerio!